I installed the install one API based kit for Windows. It integrated to my Visual Studio 2022, but for some reason I could not execute it in the IDE. So I will just execute it in the command line instead. I concluded my research in this small code base here. We have three compilation, the same main.cpp. So the first one is compiled to target the Intel graphics. The second one is compiled to target the Intel CPU. And the third one is compiled to target the NVIDIA graphics. So the code base is this one. It will just add the squares of each element of the array. So square each of these elements, and after doing that, add all of them and print the result. So this is embarrassingly parallelizable data structure because the squaring of each element is completely independent of each element. So you can square 3 at the same time, you can square 7 and it will not be affecting. So consider that this squaring operation is a big task for its element array. Here is just the squaring operation. So it is inherently parallelizable. Okay, so this is how it's done. It has similarities to how it's done in CUDA, where it involved a kernel and you submit a task here. So there's also similarities in terms of memory, the copying of memory from host to device. Host means the CPU, the device is the GPU, for example. So the array is first exists in the host CPU, but then it is copied into a GPU here, and then a parallel for loop is involved here through a kernel. So this is the squaring operation. So imagine that this I here is involved in parallel. So there are many I's. Each of them is different. So probably it is trying to access 2, it is trying to work on 0, it's trying to work on 6. So this is what's happening here. Each element is being processed. And then the result here is we copy back from the GPU back to the host CPU and then print the result. So let me do how that's done. In Windows, you have to use the DOS command because um, the oneAPI is set to be used for DOS. So right now, we don't have the command. So you have to set the environment variable. Set the environment like that. And then first, let's try to type ls. So we now know that we have 3 compute hardware. The first one is the CPU. Okay, this is the CPU. The second one is the built-in graphics of the motherboard or the CPU. And the third one is a separate GPU from NVIDIA. So As we go back here, we compile the main.cpp to target each of these compute hardware here. So because I do not have for some reason I did not have the Intel graphics, probably the the driver plugin installed. So if you compile that and run it, um, wait, it will go to the code base here. So it's printing that it's using the Intel CPU, but it's not printing the result because there is an error, access violation somewhere here. I still don't know the reason though, so cannot use the Intel graphics. But let's try the one to target the Intel CPU, and we computed the sound squares, which is 206, and we also printed the square root element. So mainly the CPP is computed using the traditional CPU, which is a sequential operation. But we can also do it, also use the graphics card to parallelize the operation. So there we get the same result and it's much faster. This speed up would be noticeable if the array is too big. So you can see that the difference can range from what would take a day to finish would take a minute if done in the graphics card. So that's the scale of speed that we're looking here. So this is the basics of uh, Intel oneAPI DPC++. The data parallel C++. It is just your modern C++ with additional uh, hormones to adrenaline to to delegate parallelizable tasks to specific hardware, such as an FPGA or GPU. But it can also run in a CPU. There will be no speed advantage if the target is a CPU. So this is all for now.